This is a revolution in physics. Wormholes don't actually exist, and we've completely misunderstood Einstein. And this completely changes our understanding of black holes too.
And from the Big Bang itself. Brace yourselves, everyone. Today, we've got a full-blown physics identity crisis. I promise.
Who among you has seen the movie Interstellar? And what did you think of it? Feel free to let me know in the comments. In that film, a wormhole, a passage through space-time, plays a key role in the plot. And that's exactly what we're talking about today. If topics like this fascinate you as much as they do me, why not subscribe to the channel right now? It only takes a click, but it helps me immensely. Thank you so much.
And if you've already subscribed, a thumbs up really helps the video. Let's try to hit 5,000 likes. The YouTube algorithm loves that. Thanks a lot, guys. And now on to one of the most fascinating misunderstandings in the history of physics.
We're talking about wormholes, those mysterious tunnels through space-time that seem to serve as cosmic shortcuts in practically every science fiction movie. From Interstellar to Star Trek, these glittering portals are everywhere, allowing spaceships to simply jump from one galaxy to the next. And the scientific origin of this idea?
An essay by Albert Einstein and Nathan Rosen from 1935, the so-called Einstein-Rosen bridge. That sounds rock solid at first, right? Einstein said it, so it must be true. But here's the problem. Einstein never said that.
A new study, just published in the renowned journal Classical Quantum Gravity, makes this clear with startling clarity. The research team led by Professor Enrique Castanhaga from the University of Portsmouth took another very close look at the original 1935 study and reached a conclusion that has the physics world abuzz.
The Einstein-Rosen bridge is not a wormhole. It never was. What Einstein and Rosen really described in 1935 was something fundamentally different, something that reaches deep into the structure of time itself. And that, by the way, solves one of the biggest unsolved problems of modern physics.
What exactly is a wormhole? The popular conception goes like this. You take a sheet of paper, fold it in half, and pierce through both layers with a pencil. Boom. Points A and B, which are actually far apart, are suddenly directly connected. No long detour, just right through the room. Sounds simple, sounds practical, but unfortunately sounds like wishful thinking, because even in Einstein and Rosen's original work, there's a crucial problem that's often overlooked. While they described a mathematical connection between two regions of space-time, this connection collapses so quickly that not even light could pass through it.
A tunnel through which literally nothing can pass. Completely useless as a travel route, much like the Brenner Pass right now with all the traffic jams. The idea of turning it into a traversable wormhole came much later from other physicists and requires exotic matter, which no one knows if it even exists. Hollywood took this idea, souped it up, and the legend was born. So what did Einstein really mean? This is where it gets fascinating. Gaston Giribet and his team conclude that Einstein and Rosen had a quantum mechanical problem in mind, not a geometric one. They wondered how to describe quantum fields in an extremely curved spacetime, for example, right at the boundary of a black hole. And in doing so, they encountered a mathematical problem. The equations of general relativity require, if you take them seriously, two directions of time simultaneously. One that runs forward, as we all experience time, and one that runs backward. The bridge that Einstein and Rosen described is therefore not a physical shortcut through space. It is a mathematical connection between two directions of time. The new understanding of the Einstein-Rosen bridge therefore has nothing to do with classical wormholes, according to the researchers. It's mathematics, and it's mathematics that has been right in front of our eyes the whole time.
Imagine you're reading a road map because, say, you want to drive over a mountain, but you misinterpret all the terms on the map and end up in a lake.
That's roughly what happened in science with the Einstein-Rosen bridge. Everyone read the term bridge and thought tunnel, but Einstein meant something far more abstract.
A formal connection between two mathematical regions that does not represent a real path through space, but rather describes a property of time. And this difference is no small matter, because if this is true, it simultaneously solves a problem that Stephen Hawking raised in the 1970s, and that has haunted physics ever since. You may have heard of Hawking radiation. The idea is that black holes slowly emit energy and eventually evaporate completely. A death by installments, very slow installments. But what happens then to all the information, that is everything that has ever fallen into the black hole? Quantum mechanics insists that information cannot simply vanish. General relativity says it can. The black hole is gone. A direct contradiction between the two most powerful theories in physics, and this is known as the black hole information paradox, and no one has solved it yet. But that may have changed because the new study now claims that the paradox resolves itself if one takes the second direction of time seriously. The information does not disappear. It continues to exist, but mirrored in time as a component of the quantum world. We cannot see it directly, but it is there. The researchers explain it this way. The paradox arises in the first place because we have so far only considered black holes with a single direction of time. If both directions are taken into account, the information is preserved at the event horizon. It continues to evolve in the time-reversed component of the quantum state, just outside our direct reach.
Absolutely crazy, and yet more elegant than any solution so far. And guys, now it's getting really wild. The implications of this idea even reach back to the Big Bang. Pay close attention now. If time at the quantum level has two directions, then the Big Bang was possibly not an absolute beginning at all.
Hey guys, quick request. YouTube is currently being flooded with hastily thrown together AI content, so-called AI slop. This isn't meant as general AI bashing, but it does make it harder for human creators to stay visible. This video here is not AI slop. It was researched, written, and produced by hand by several people who make their living from this. An editor, a video editor, a marketer, and myself. If content like this matters to you, your subscription helps us tremendously. Every subscription to the channel ensures that we can continue to put time and energy into real, carefully crafted videos. Thank you so much, everyone. And now, let's continue.
It would then be more of a transition, a quantum leap from a collapsing universe to an expanding one. Not the beginning of everything, but a cosmic turning point, a reversal of time. Our universe could therefore even be located inside a black hole that formed within an even larger cosmos. It all sounds like science fiction, but this idea is now mathematically substantiated and is being discussed by serious physicists. The researchers also bring observations into play. The cosmic microwave background, the echo of the Big Bang that permeates the entire universe, exhibits a persistent asymmetry that standard models cannot cleanly explain. Models that account for two directions of time fit the observational data much better here. That's not proof, but it's a clue. And in physics, whoever explains the observations best is usually right.
So what does all this mean now? No wormholes as cosmic subways. That's the bad news for all interstellar fans. The good news, what Einstein and Rosen actually described, is at least as spectacular.
The mathematical bridge between two directions of time could explain why information is never lost in the universe, how black holes really work at the quantum level, and perhaps even what came before the Big Bang. Not a tunnel through space, but a window into the hidden architecture of time itself. Let anyone say science isn't exciting.
And they say science isn't exciting. I'll keep you updated on all the latest exciting discoveries. So feel free to subscribe to the channel and don't forget to give it a thumbs up so we can hit 5,000 likes.
And now that we're questioning the very foundations of our universe, what if the universe itself isn't what it seems to be? New cosmological discoveries are currently causing real confusion among astronomers, and some of them suggest that our entire reality is being put to the test. I'll show you exactly what's behind this in the video displayed at the top right. As always, you'll find another topic related to science and space at the bottom right. Otherwise, I'd say see you in the next video. Take care, everyone.